Okay, this is a bit of a follow-up to my last video, as the responses to that from our opposing side on the globe, whereas as I expected. Okay, just going to go through some basic stuff here. This is going to be a challenge for them because due to claims they've made. Some basic stuff, right? They want to, from the last video, just so, whoops, go back there. Right. They want to deny this green line, which is the opposite. When you're measuring a right angle triangle, right, you're measuring, right, you have an adjacent, an opposite, and a hypotenuse. Let's say this here I have, is a mountain, right? You're measuring the angular height of the mountain, right? Now, if you have the actual height of the mountain, well, whatever it might be, and you know that actual height, the angle you get will give you your adjacent length from the GP point of the mountain, which will be there, let's just say, right? So you can find out exactly how far away from this point you are via knowing the length of this line, right? Now, if you know the length of this blue line, right, from the observer to this point here, then you can know via that length with your angle, you can determine the length of the green line, right? So knowing the length of the green line with the angle will allow you to know the length of the blue line, or knowing the length of the blue line, right, with the angle will allow you to know the length of the green line. Just basic, that's trigonometry, okay? Now, when it comes to celestial bodies, it doesn't work that way. You're still using a right angle triangle, and this is the thing. Our opposition need to oppose the right angle triangle as much as possible, even though, and they don't know this, the majority of the idiots we deal with, they actually use them in their own system, right? Now, it's only a mathematical system. It's not a real system because you're not measuring it in reality on a globe, because globes don't exist. Or sorry, the globe doesn't exist in reality. The Earth is not a globe. It's demonstrably horizontal plane with vertical heights above and below that horizontal plane, heights and drops above and below that horizontal plane. But they have to hijack those measurements to mathematically create a globe, right? As I've pointed out over the years. Now, what they want to do is they want to deny that when we're dealing with a celestial body, I'm just going to use Polaris, right? Because this is the challenge, right, of this video, is for the Polaris to give us the height of Polaris, right? And I'm not talking about within their BS paradigm. I'm talking about in reality, and I'll get to that at the end of the video. I have up here Polaris unattainable distance, because Polaris technically doesn't have a distance. Neither do any of the rest of the celestial bodies. Because for Polaris to have a distance, right, from Earth's surface, let's say this is its GP point here, right, and this is Polaris here, it has to, right, it would have to behave as the same as the top of this mountain. Because what this mountain has here, right, or the mountain depictions, right, what that has is a consistent geometric location. Because it is a geometric object, right? We don't know what Polaris is to say what it is or isn't, but it doesn't hold a consistent geometric position. Nothing in the sky does, right? There's nothing consistently nothing in the sky that holds a consistent geometric position, right? There's no stars, anything that will hold a position when it comes to the measurement in angle of it. This mountain, right, will hold a consistent geometric position. We can measure the height, the length of this green line, the opposite. We can measure that, right? And we can measure this blue line, right, the length of this blue line. We can measure both of those, right? And as I said earlier, we can determine the length of the green line with the angle and the knowing and the know. Sorry, we can determine the length of the green line with the angle we measure and the known length of the adjacent, or we can determine the length of the blue line right, with the angle and the known length of the opposite, right, with trigonometry. With a celestial body, you cannot do that. Now, if you want, you can decide, right? I'm just going to show, right, as an example. Sorry, I'm going to just go here. Just going to get the length. If you want, after you've used the processes that's used in celestial navigation and astronomy, sometimes too, right? Astronomy as well, right? Because they need to sometimes know distances. You can go, let's say a 6, right? You can say that, let's say we'll use the 60 degree line. That will give you a distance from the GP of Polaris of 1,800, right? 1,800 nautical miles, right? So I can go, right, take that 1,800 and the 60 degrees. I can go to, let's say, a right angle triangle calculator, right? I can go and say 60, put it into here for A here for the angle, right? And I can go 1,800 for B, right? 1800. Now, and I can press, right? Now, I can press calculate, right? And A, right, the length of A will be 3,117, right? That's the length of A. So, according to this right angle triangle calculator, and according to the Polaris should be 3,117 feet high off of the surface of Earth. But if I then use 50 degrees and not 60 degrees, so 50 degrees and a distance of 2,400 nautical miles. And remember, as I said, I'll get to that in a second, about how we gain the distance. So I'm going to use 50 degrees, right? I'll use 50. Now remember, it was 3,117, right? I'll use 50 instead of 60, and I put in 2,400 here, right? 2,400, it'll be 600 more. And I press calculate, and I get 2,860. Now that would mean that according to the Borders, as they treat Polaris, as they want to treat Polaris like the top of a mountain, and they want to state that we should be able to get the correct height of Polaris with trigonometry if we're using an elevation angle, or if we're using a right angle triangle, because they want to strawman us, right? But we're still using a right angle triangle, right? Because this vertical here up to the 50 degree mark, right? And then this, right, that's the opposite. Then we have this orange line down to here, which is the hypotenuse, and this portion of the black line from here to here, which is the adjacent. It's still a right angle triangle. You're always, because you're measuring, as I said, stated over and over and over in the last video and in previous videos, you're measuring the opposite. But because Polaris doesn't hold a consistent geometric location in the sky, like the tip of the mount, like the top of a mountain does, because it doesn't do that, it means that you're going to get a different apparent height to it every time you change the angle and the distance, because the distance is going to give the distance will give you a different angle. So if you're getting 60 degrees of an angle to Polaris, then that means that you're 1,800 miles, nautical miles from its GP. If you're getting 50 degrees, that means you're 2,400 nautical miles from its GP. But these degrees are just an angular height, but they're an angular measurement of the opposite. Now, as I showed, you can do trigonometry, but you will not get a consistent height. If I have a height of this mountain here, if it's, let's say that mountain is, let's say 1,550 feet, right? And that's right from sea level up, and I'm measuring from sea level to the mountain, and I have an angle of 6.009 degrees, right? So I'm just going to go here, I'm just going to clear, right? So, so the height of the mountain I'm going to is, right, 15,500, I meant to say, 15,500 feet, and the angle is 6,009, right? That's the angle, right? and I press calculate, right? Sorry, less than, what am I doing? Oh, sorry, I meant to put in, I knew that, I didn't put in the 6.009, right? I didn't put in the decimal place. That means that my distance from it is 100, if I'm dealing with feet, it's 147,250 feet, because I gave a height in feet. So with the angle of 6.009 degrees and the height of the mountain 15,500, right, I keep A the same, that never changes, right, which is my here, and my angle will change, but A never changes. And if I change my angle to, let's just change it to 4009, press calculate, I get a different distance, right? 221,161 feet, right? I get a different distance from the GP of that mountain. But the mountain here doesn't change. A never changes, right? But when it comes to Polaris, or one of the celestial bodies, we don't have A. Right, and the only way we can get some ad hoc A, right, to put in the ad hoc figure to put in for here, is only after we have already used the celestial navigation process of determining our straight line horizontal distance from the GP of that celestial body, Polaris in this scenario. So, as I showed earlier, a 60-degree angle and a 50-degree angle, right? If I'm just using the distance that I gain via, let's just say my angle is 50 degrees, I subtract that from 90, gives me 40, then I multiply 40 by 60 to get 2400, right? Because that'll be my zenith distance. The point being is that distance is a horizontal, right? That's my angle is off of this horizontal here. It's up along the vertical. So I'm using a horizontal, the adjacent, a vertical, the opposite, and then I have a hypotenuse, which is my angle line. So once I go through the process using celestial navigation, I can then have a distance along the adjacent. But that distance along the adjacent will never give me a consistent height to the celestial body. Because it's not like with the mountain. It's not the same. There isn't a consistent geometric location. Like, I won't be able to just use that distance right along the adjacent to gain a consistent length or height to the opposite. It'll never happen with a celestial body because they don't behave like something terrestrial that holds a consistent geometric location. If they don't behave that way, I can't gain this length of the opposite. Every opposite length will differ with the angle and distance. Every one of them. It won't with the mountain, right? Well, because I know I have a consistent geometric location for the mountain and a consistent geometric height. I don't have that with Polaris or one of the other celestial bodies. That doesn't exist for that. They don't behave like a mountain or a skyscraper or a tower or anything else. They don't behave that way. So I still have to use a right angle triangle, but I can't use trigonometry and expect to gain an actual height, consistent height to Polaris, because it doesn't have a height, an attainable height or distance. It doesn't exist. It doesn't behave it doesn't behave like terrestrial objects. Somebody wrote a comment in the last video, you might see it there, there's hundreds of comments. So you're saying that Polaris is magic. So there's this Polaris and the star celestial bodies are magic, and they go up and down like yo-yos. Yeah, that's pretty much it. Like the guy thought he was having a go at me, not realizing that, yeah. And it's not that I think that, that's what it does. Polaris acts, and the other celestial bodies act as if they're magic in comparison to the terrestrial objects we usually deal with. And they do appear to rise and fall, right, with the observer. So if the observer goes up in an airplane, takes an angle to Polaris, right, and they're above the 45th degree latitude, they'll get 45 degrees. The person in the boat that's taking an angle to Polaris, once they're both north of the equator, and take the person in the boat was over 45-degree latitude, they'll get 45 degrees. The person on the mountain with the artificial horizon, taking an angle to Polaris, will still, if they're at 45 degrees, if they're past north of the equator, they're still going to get 45 degrees. So the angle is the same for all three, even though all three individuals are at three different elevations or altitudes. One is at sea level, one is on a mountain, and one is in an airplane 6 miles above the earth. So how can they all three of them get a 45-degree angle if they're at the same latitude? How can they all get the same angle to the same celestial body at three different altitudes, three different elevations? Right? Because Polaris and the celestial bodies are not like terrestrial objects. No matter how much our opposition want to make them be the top of a mountain, they will never be that. They can't be that. That's why we can't use trigonometry to gain the actual height of Polaris, because it doesn't have a height. How can something have a height if it appears to rise as you rise and it appears to fall as you go down, as you fall, or drop as you drop? Do you know what I mean? Descend as you descend. You can't measure a height to something like that. It's a case of, it's crazy for people maybe to take on board, but the celestial bodies are kind of magical. That's the only way I could describe them. We have no reference on Earth that matches what they are and what they do. We can't in any way match them for what they are. We have no, the Polaris or this celestial body is kind of like this thing over here, or this thing under the water, or this thing up. Nah, on the mountain, there's no such thing. We don't have any reference. They're like in a completely different paradigm that we do not understand. And as soon as our opposition start accepting that, then like their forefathers did, even though their forefathers were frauds and still are, they at least accepted that the celestial bodies are not, which I will show in a minute, are not what people might try and make them out to be. They're not a mountain. They're not a tower. They're not a cliff. They don't behave that way. That's why you can't use trigonometry to gain their actual height, because they don't have a height. There is no height to Polaris. It doesn't exist. We don't know what Polaris is. Can't give it any height, give it anything like that. See, the thing is that our opposition to even gain, even Strawman us, they must first use the process used in celestial navigation, which uses a right angle triangle, because you're measuring a vertical, an angular vertical height up along the opposite. You're measuring the opposite. Like every elevation angle, all angles of elevation are the exact same thing. They're all right angle triangles. And as I showed, you can do trigonometry, but that won't give you a consistent, it'll only give you an apparent height. So you have an apparent height with the angle, then you have an apparent height in feet and miles or whatever, meters. What good is that? You have an apparent height with the mountain with the angle, but you have an actual height also. You don't have that with the celestial bodies. You don't have the actual height. So when our opposition tried to strawman us, they, with this stupid argument about, oh, well, you can't get if you're using right angle triangle, then you surely get a height to Polaris. No, you can't, bozo, because Polaris is not the top of a mountain. Right? These idiots, they don't want to address reality. They attack us constantly because they're very scared people who do not want to address reality. It's that simple. We're not responsible for what reality is on the flat earth side. We just point out what it is. I'm not responsible for what reality is. So me pointing out something in reality, does that mean I deserve to be attacked? I'm just pointing out that this is this, and that's just the way it is. So why are you attacking me? I'm not responsible for that. I'm not responsible for the reality that our opposition are terrified of. I'm not responsible for that. I'm not the creator of it. I'm not God. I didn't create any of this. I'm just pointing out that's what it is, just like many other people have. But our opposition do not want to address reality. Yet, right, this is the joke. In their own paradigm, right, they must to even mathematically do any celestial navigation using a globe after all the measurements have happened on a flat earth, they must then move the position of Polaris. So this is a person in the boat in reality, right? This is being sea level. This is the celestial body, Polaris, whichever, right? And this is the GP point of the celestial body, right? On mean sea level, right? That's the GP point, the geographical position on Earth, right? At that moment, or if it's Polaris, it'll be a consistent position. Here is an airplane, right? Someone with an aeronautical sextant measuring the same angle over the same position at the same time to the same celestial body, and directly below that celestial body, let's say we'll use Polaris because it's the easiest one, because it's stationary. This is directly, so their opposite will be directly above the GP in reality. So you have one right angle triangle from the boat, let's just call this 27 degrees, right? I don't know what it is, doesn't matter. We just say 27 degrees, and they have, that measures out this straight line here and puts the GP directly below Polaris there. The same for the person in the airplane. They measure, but they're 6 miles above the person in the boat. They're over the 45th degree or the 27 degree latitude, and they measure 27 degrees to Polaris, and that places this point here, which is the right angle triangle, right, that they have, will be directly, right, above the GP of Polaris. So in a straight line down, straight down to here, where there will be, right, so all you're doing is taking this right angle triangle and placing it at mean sea level. That's what you're actually doing. Now, for them to use it on the globe, mathematically, for them to hijack these things, they have to then take this right angle triangle and move it right down to the center of their globe. Now, I'm not going to go into vernal equinox and all this because it absolutely annihilates them. And there's another thing I've pointed out in the past that I'm going to do another video on concerning the airplane that absolutely obliterates their nonsense, right? But for now, I'm just going to stick to their hypocrisy, because they then must move Polaris from here to here to here. So it doesn't matter if it's a person in a boat or a person in a plane that measures the angle to Polaris, 27 degrees, let's just say. Then when they try and hijack it for a globe, they then must move Polaris down as well, or whatever celestial body, placing the GP here as opposed to directly below it, because for them, the GP is in from Polaris on the surface of their globe, as opposed to directly below it like it is in reality. So these hypocrites and idiots on our opposing side want us to know what the height of this thing is, right? Right? How can you know the height of this thing when the angle this person is taking is 27 degrees? This person's directly above them, 6 miles above them on an airplane, is getting 27 degrees, and then the ballers mathematically must then place the angle at the center of their nonsense globe, and have a joke GP on their globe here, and they must then mathematically bring Polaris down. So they know that Polaris doesn't hold a consistent position. They know it so much that they're able to mathematically place it into a mathematical position for them on the globe. So they're fully aware that it doesn't behave, none of the celestial bodies behave as terrestrial objects, yet they want to ask us to give them a height to Polaris. The level of dishonesty and terror within them people is it's astounding, but they're willing to say anything and lie, be dishonest, keep asking the same question when they know that there's no way that me or anyone else can give them a height to Polaris. It's not possible. Because, as I said, the person from the boat, 27 degrees, sees Polaris here. The person in the airplane, 27 degrees, sees Polaris there. So is Polaris here or is Polaris here? Because for both of these observers, right, it's in two different locations, two different apparent locations. And why is that? Because it doesn't hold a consistent geometric location which is why the bowlers can move it down here mathematically, right, and completely change where the GP is and pretend that they measured a curved line. It's stupid, but that's what the nonsense. So with all our questions about the height of Polaris, blah 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 blah, give us the height of Polaris with your right angle triangle, which you have to use to do the measurement, right? Give us the height of Polaris, blah blah blah. They then must take that same triangle. They don't even realize that they're using a right angle triangle with vernal equinox. They don't even know that. I went to that in a different video. They're thick, right? But they're also dishonest because they know that for their maths, right, after reality has happened and they mathematically then want to place these positions on a globe, they must then bring Polaris down. So they're fully aware that Polaris does not hold a consistent geometric location, right? If I just show you in something, right, a slightly more to scale version. Here is an angle from an airplane, right? I have question marks here because airplanes don't fly on globes. It's 29.17 degrees, right? Here's an angle down here, 29.17 degrees. There's some small differentials after that, but there's only tiny little things. And you have a length here of 4,200. This is in statuette miles, okay? Because I put the globe in statuette, or the circle here in statuette miles. The same here, 4,200 statuette miles, right? So this means that the apparent star position here, right? We'll just say star, any star, or Polaris, any star. The apparent star position here, that's going to be seen from the airplane, right? That'll give the pilot the information that the GP of that star is here, right? Horizontal, right? Or sorry, is directly below there, I should say, right? That is going to be used by the bowlers, and they're going to take this apparent star position and bring it down here. That's what they're going to do. Yet they're going to ask us to give them the height of the star with a right angle triangle. The very thing the right angle triangle that they need to use to measure, right? That they're using to measure the height of these things. They then want to strawman us and ask them to give them the height of the celestial body after they mathematically even bring it down. It's shocking, the level of dishonesty with them. But that's what they want to do. So, as they keep claiming that we should be able to get, right, the apparent, or the actual height of Polaris, even though they know that it's not possible because they know that it doesn't hold a consistent geometric location, as they want to strawman us with that, then here is my challenge to them. Please take, right, two angles to Polaris. I'm going to give you 63 degrees and 54 degrees. Please, with both of those angles, give me the same exact height to Polaris. The same exact height to Polaris. And you're not allowed to use, right? You're not allowed to use the celestial navigation method of finding out the distance from its GP. So, you want to strawman us, then you're not allowed to use this process to find out the distance from the GP, the celestial navigation process, and you don't have a height to Polaris. You have two angles, 63 and 54 degrees. Because according to you fools, that's all we need. We don't need to know the height of it. We can get the height from the distance. Then you figure out the distance without using the celestial navigation method, because that's a separate method where you're using a right angle triangle, but in a separate way. Figure that out, right? And then without using that method, and then give us the exact same both distances that you figure out, right? For the 63 and 54 degrees to Polaris, right? Both adjacent lengths, right? Must give us a consistent opposite length, as in reality. So whatever it is, 8,000 miles or whatever it is for both has to be for both. Because what they're going to have to do is they're going to have to use the celestial navigation, as I've gone through in a separate video in the past. They have to use the celestial navigation method to find out the length of the adjacent, and then they have two angles, 63 and 54 degrees. So even if they do that and get the adjacent lengths, right, they still then need to come up with a consistent and correct Polaris height. So actually I actually changed my mind. Do use the celestial navigation method, which means that you have to use the celestial navigation method before you can even try this nonsense you think we should be able to do. 63 degrees and 54 degrees, get the adjacent lengths, and then come back with a correct and consistent height to Polaris with both those angles. There's your challenge. So if what you're claiming is true, that Polaris is something that has a consistent geometric location in our sky, if this is true, as you keep on trying to straw man us with, then you fools will definitely be able to come back with the exact same height for Polaris, right, and a correct height that can be shown to be true using the celestial navigation method to determine your adjacent lengths with two angles, one of 63 degrees and one of 54 degrees. Both angles should give you the exact same correct height to Polaris, according to you. Because according to you people on the globe side, Polaris, it must hold a consistent geometric location. According to you, all the people in my comments in my last video and other videos, it must hold a consistent geometric location. It doesn't appear to rise and fall with the observer, according to them. It doesn't appear to do that. Right? So if that's the position you want to hold, then not only do you have to deny how the maths are done for your globe after the measurements are taken on a flat Earth, but you also then must come back with an actual correct and consistent height for Polaris for any angle that we take to it, just like we can with the mountain, because you're treating Polaris like the top of a mountain. So off you go, ballers. Let's see you do that. I know you won't. I know you'll come up with every kind of rubbish excuse in the comments to not have to deal with it. I know what you're going to do, which is nothing. That's all you ever do. Any challenge I put towards you that will prove or disprove something, you all just run off. You're just cowards when it comes down to it. You never do any of this. I know that you're not going to be able to do this. You know you're not going to be able to do this. So, but as you keep on asking us to do it, I'm going to put it now on your doorstep. As to do this, you asking us to do this means that you're expecting that we must treat Polaris as if it has a consistent geometric location, just like you're straw manning us with. So you do it now. You have the two angles, and I'll even forego you using the celestial navigation method. I prefer you weren't even using that, because then you have to get some other way to find an adjacent length, right? So that means you just have an angle. But I'll give you that just so you can come back with a consistent and correct geometric height to Polaris, something that doesn't have a geometric height or any distance. It's complete. Whatever it is, it has no relation to anything terrestrially. But according to you fools, it does. So ballers, off you go. There's your challenge. Thanks for watching.